guys, and welcome back. So today we're going to be talking about fetal circulation. So what is fetal circulation? Why is it needed? And how is it different than normal circulation? So before we start, let's talk about this. So this image was made by Henry Van Dyke Carter. So what's going on here? So the baby is inside of mom, and so one of the things is you notice there's not a whole lot of oxygen here. Why? Because the baby's floating around in amniotic fluid. And so the fluid does a couple of things, protects the baby and so on, but not so good for the baby trying to get oxygen. So the baby has to get oxygen from mom. Well, how does this work? Well, the baby pumps blood to the umbilical cord, and it's getting blood to the placenta. So the placenta is getting somewhat oxygenated blood. Now, the oxygen level in the arteries of the placenta is a lot lower than what's in the mom's blood, normal arteries, stuff like that. And so we're sucking oxygen from mom, and we're taking this back to our body right here. And so the umbilical veins has oxygen-rich blood. Well, the liver needs some oxygen, but not a ton. And so what's going to happen is we're going to have some of this oxygen-rich blood go over here to the liver to supply the liver with what it needs. Most of that oxygen-rich blood is going to bypass that liver right there, right? And so we're getting a little bit of mixing of deoxygenated blood coming from the lower body, but most of this oxygen-rich blood is just skipping that liver. And so we're coming in here, and we got deoxygenated blood coming from the upper body as well. Well, we have a couple of problems here. Number one, if we let this blood take the same course that it does in an adult, we're going to pump all this blood out to the lungs, and the lungs are going to suck back a lot of the oxygen out of it. And so the blood that's going to go to the brain isn't going to have as much oxygen in it as what we would like. And so that baby's brain is very sensitive to any sort of oxygen level. Right? And so, as I said, we're trying to minimize the mixing of oxygenated blood with deoxygenated blood. And so what we're going to do is we're going to let this blood skip from the right side of the heart directly to the left side of the heart without going through the lungs. All right? And so the reason why this is happening is you have a foramen ovale. And so basically it's an oval opening is what that means. And so, as I said, it's allowing the blood to skip the lungs. So we're saving the best possible blood for the heart and for the brain. All right. So next thing that we got is we got this oxygenated blood that's over here on the left side of the heart in the left atria. Well, guess what? We have a little bit of deoxygenated blood coming over here. From the lungs. And so we don't want a ton of deoxygenated blood. So how do we prevent that? Well, one of the ways we do this is by minimizing how much mixing we have right here. So we had a little bit of mixing of the blood from the left from the upper body and from the lower body. And so this oxygen-enriched blood, normally it would all go out to the lungs in an adult. But we have this ductus arteriosus right here. So we got another bypass. And so we're going to allow this oxygen-enriched blood to skip the lungs. So between 90 to 95% of all that blood that would go to the lungs is skipping the lungs right here. And so now we're missing the lungs. Anyways, because we're only having a very little blood going over here toward the lungs, we're only having very little blood coming back from the lungs. And so we got a lot less mixing happening here. And so now this left ventricle is going to pump the blood out to the aorta just like it would. The big reason for this though is we're saving the best possible blood. We've had as little mixing as possible with blood going from the body, upper body, and so on. And so the oxygen level is going to be much higher than what it otherwise would have been. And so we got a high oxygen level for the heart and a high oxygen level for that developing brain. Meanwhile, the oxygen-rich blood that's been pumped out through this ductus arteriosus is now able to mix with the oxygen-rich blood that didn't go to the brain or to the heart. And so it's this blood right here that's getting pumped out through the umbilical arteries to mom. Now, one of the big things is this oxygen level is a lot lower than what is normal for mom. But the reason why the baby is able to put up with this is because the baby has a very high red blood cell count. And then on top of that, the red blood cells are actually designed to be able to offload more oxygen at those levels of oxygen that's normally found in this circulation right there. So very, very important. The other reason why we care about fetal circulation is when you're born and you start breathing oxygen, out of nowhere, the oxygen level in this goes really, really high. And so what that's going to do is it's going to cause the placental arteries to cut off. And so usually that's going to happen within 10 minutes. You're not getting any more blood flow through here. All right, and so because no blood going into the placental arteries, no blood's coming back through the placental veins. And the other thing that will happen is because the oxygen level is going higher and higher and higher in the blood, what's going to happen is it's going to become a lot easier to get the blood to go through the lungs. And so what happens, that foramen ovale is just a flap valve right here. And so what's going to happen is it's like this. So as long as the pressure over here is higher than what the pressure is over here, blood can leave the right and go over to the left. But if this were to reverse, and this become the high, this become our high pressure, and over here, this becomes our low pressure, what's going to happen is the blood will want to flow the other way. But the problem with that is this is a flap valve. And so what's going to happen then is that valve is going to shut. And so right here, now it's nice and shut, and guess what? No blood can go back this way. It's been blocked. Well, 1 out of 5 people, this doesn't fully shut after birth. So normally, in a normal adult, this fuses. But in about 1 out of 5 adults, this doesn't fully fuse. And the reason why this becomes important is if you cough or sneeze at just the wrong time, you can actually have a little blood clot over here. And because you cough, you have to make the pressure super high, and now that blood clot can skip over here, and instead of getting caught in the lungs, where you might have a little bit of chest pain, shortness of breath, it can go over here to the heart and cause you to have a heart attack, or to the brain, cause you to have a stroke, or some other problem. All right, and so that is fetal circulation, and that is why we care. Right there about the foramen ovale, which is skipping the lungs, and the ductus arteriosus, which also helps to skip the lungs. And it's breathing in and out, getting that high oxygen blood that's shutting these pathways down shortly after birth. Well, I hope all that helps, and I will see you guys next video.